All right, so today we're reviewing for the Unit 13 test. That means that there's a lot of formulas in this unit, and we need to be able to keep them straight. So in order to help us keep them straight, we've made like a little grid at the top that we have to identify what each of these are. The big deal is you're going to have to know which formula. First, you have to memorize all of them, so let's make a little note. Must memorize and know which formula to use. Because each formula is used for a different situation. So the first really big thing is we have to know which ones are arithmetic and which ones are geometric. So when I'm looking at this formula, I know that this first one is arithmetic. Part of that is because it has the D for common difference, which means it's going up by the same amount each time. When I look at the next one over, this has exponents that have a variable, so I know that this one is my geometric one, so I'm going to have that one memorized. Then I keep reading on, and this one, again, there's no exponents in it, so that should probably tell me that we're dealing with arithmetic, so that's kind of a key thing to help you remember. So arithmetic. Then when I look at this one, again, exponents are involved and the common ratio, so that tells me that this one is geometric. Now this one doesn't have any exponents, but again, there's that R there, which stands for common ratio, which means we're multiplying to get to the next thing, right? So this one would also be geometric. Now the question is, which one do I use when? Well, this is arithmetic, and this one is to find a single term. We can also use it to find pieces, like if we didn't know what the common difference was, we could use it for that. Whereas this one over here that's arithmetic, we see that S, and remember that that S stands for sum, so this is to help you find the sum of the arithmetic sequence. So if we're trying to find an individual versus we're trying to find the sum of them. Now when we look at geometric over here, again, this A sub n tells me that I'm looking for a single term, so this one helps me find a single term. But as I look at these ones, there is an S, so that S tells me for both of these that they are a sum. Now remember, geometric sums are different depending on what type of series it is, right? If it's an finite series versus an infinite series, they have different formulas. So this one is the sum for a finite series. And we know that because there's this n in the formula telling us that there's an n number. This one is for an infinite series. Remember, this is the one that's never ending. Okay, so as we go through these problems, you're going to have to identify, is it arithmetic or geometric? And then, is it for a sum or just a single term? So looking at the bottom, it says classify each as arithmetic, geometric, or neither. And then there's a second step saying to find the formula for A sub n. So if we're trying to find the formula for A sub n, this is for a single term. So we don't even have to worry about the sums in this one. All we care about are these two, because these are the ones that help us find a single term. Okay, so identifying if it's arithmetic or geometric. Remember, if we're given a list of numbers, arithmetic tells us we're going to have to add / subtract the same number to get to the next term. Geometric is we are going to multiply / divide, right, to get to that next term by the same number every time. And neither obviously means neither one is the case. So I always check first to see if we're adding the same amount. So from one term to the next, what would I have to do? So to get from 4 to 8, I could either add 4 or multiply by 2. But 8 and 12, so I'd start out with adding 4 and see if it keeps going. So I add 4 and I get to 8. 4 plus 8 is 12. 12 plus 4 is 16. 16 plus 4 is 20. So since I'm adding the same amount every time, this is arithmetic. So that's the first part of my answer. It's arithmetic, and I know that because we add same amount each time. And so we're trying to find the arithmetic, which means this is our formula, a sub n equals a sub 1 plus d times n minus 1. And since we're writing a general formula, remember that that reminds me that we're going to keep the a sub n and the n general, right? And then we have to figure out, well, a1 is the first term, right? So my first term is 4, plus the d, which is my common difference, which here was 4, times n minus 1. So a sub n equals this. So now we're going to have to simplify that. So we distribute in. We get a sub n equals 4 plus 4n minus 4. Right? We can combine our like terms. Well, 4 minus 4 zeros out, so those go away. So a sub n equals 4n for this formula. Okay, so now let's look at the next formula. So the next formula, we have to see again, is it arithmetic, geometric, or neither? And we should look at what's happening from one to the next. Well, to get from 1 to 4, I'd have to add 3. But 4 plus 3 does not give me 16. So I know adding isn't it, so I know that it's not arithmetic. So then I look and see, okay, instead of adding, what would I have to multiply? Well, 1 times 4 would give me 4. 4 times 4 is 16. 16 times 4 is 64. And 64 times 4 is 256. But for the next one, I'd probably have to type that in my calculator. So 256 times 4, oh, I missed the 6. Yes, is 1024. So I know that this is geometric because we're multiplying by the same amount each time. Okay, to get from one term to the next. So my geometric for a single term is a sub n equals a sub 1 r to the n minus 1. And again, because we're doing a general one, the a sub n and n stay the same. But my a sub 1, my first term is 1, times r, which we found to be 4, because that's what we were multiplying by, to the n minus 1 equals a sub n. Well, multiplying by 1 doesn't change anything, so that's really just 4 to the n minus 1. Okay, so we move along. Next one, again, we have to look and see what's happening to help us get from one to the next. Well, negative 1 plus 3 would get me to 2, but 2 plus 3 is not 7, so I know adding 3 is not it. How about multiplying? To get from negative 1 to 2, I would have to multiply by negative 2. But does multiplying by negative 2 get me to 7? It does not. So this one is a neither, because we can't multiply by the same thing and we can't add the same thing. So this one means we're just going to have to look for the pattern like we had done previously. So I have to think, is there something, some sort of pattern here that would help me get to these numbers? So normally we would start out with squaring or cubing, right? Well, cubing would get me much bigger numbers. So I'm going to start out with a sub n equals n squared, right? Well, this one is a 1, so 1 squared does not equal negative 1. But 1 squared equals 1. And what would I have to do to 1 to get to a negative 1? Well, I would have to subtract 2. So my guess is we're going to have to subtract 2, but we should check to see if it'll work. So let's look at my second term. So my second term, right, here's my second term. I would get that by doing, so second term should be 2 squared minus 2. 2 squared is 4, minus 2 would be 2, so that works. I'd also check my third term. Well, third term would come from taking 3 squared and then subtracting 2. 3 squared is 9. 9 minus 2 is 7, so that works. And let's even check our fourth term, which would be 4 squared minus 2. 4 squared is 16. 16 minus 2 is 14, so that does work. So then this is my formula. All right, let's look at D. So what would I have to do to get from here to here? Well, because it's a fraction, I'm really thinking that adding, and because it stays a consistent fraction, I'm thinking adding wouldn't work. So to be honest, when I look at this, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So we almost think that it's multiplying by 3, right? But the top stays the same. So I'm really multiplying by 1/3 because 1 times 1 is 1. 3 times 3 is 9. If I multiply this by 1/3, 1 times 1 is 1. 9 times 3 is 27. Let's see if that stays the same. So 1 times 1 is 1. 27 times 3 is 81. So I'm multiplying by 1/3 each time, which tells me that this is geometric because I'm multiplying by the same number each time. Okay, which means we're doing a sub n equals a sub 1 r to the n minus 1. So again, we leave a sub n general. My first term is 1/3. My ratio is also 1/3 because this is my common ratio, right? And my first term to the n minus 1. Now, you could have just looked for the pattern, and another acceptable answer would have just been a sub n equals 1/3 to the n. I would have accepted that as well, because, right, 1/3 to the first power is 1/3, 1/3 to the second power is 1/9, so on and so forth. So it depends if you use the formula or if you just look for the pattern, which one you're going to get. But both of them really mean the same thing, and both of them are correct. All right, so last two for this page. So looking at this one, I'd have to see, am I going up by the same amount each time, or down, or am I multiplying? So I always track addition or subtraction first. So to get from 1 to 4, negative 1 to 4, I'd have to subtract 3. Negative 4 minus 3 is 7. Negative 7 minus 3 is negative 10. And negative 10 minus 3 is negative 13. So this one is arithmetic. Again, arithmetic just means you add or subtract the same amount each time. So we're going to use the formula a sub n equals a sub 1 plus n minus 1 times t. Now you could have had the d back here or in front. We've done it both ways. So, but because all it's saying is that you're multiplying these two things. A sub n stays general. A sub 1 is negative 1 plus n minus 1. Again, the n stays general, and my common difference is negative 3. All right, so we're going to go ahead and distribute that in to get negative 3n plus 3. Bring down my minus 1, my a sub n. Combine my like terms. So I'd get a sub n equals negative 3n plus 2. All right, last one. So when I look at this, the first thing I notice is that they are alternating between positive and negative. Since they're alternating between positive and negative, I know that it's going to have to be like a negative number, right? Alternating means we're going to have a negative number, whether it's negative 1 or what, to some power, to the n power, right? So we're going to have to look, and it's either n plus 1 or n minus 1 because it starts out positive. So since it starts out positive, that tells me n plus 1 or n minus 1, depending on how the problem works out. Well, if I'm looking for a pattern here, ignore the actual positive or negative. If I were just doing 8, 4, 2, 1, 1/2, what would I have to do to get from one to the next? Well, subtracting 4 doesn't work, but if I divide by 2 each time, we would get there. And remember that dividing by 2 is really the same as multiplying by 1/2. So this is our common ratio. So we know that this is going to be geometric. And it'll be a geometric combination of those types of things. So geometric tells me, now I also have to deal with getting the negative, right? So if I were to divide this by negative 2, 8 divided by negative 2 would be negative 4. Negative 4 divided by 2 divided by negative 2 would be 2. 2 divided by negative 2 would be negative 1. So really, my common ratio is actually negative 1/2 because that will help me take care of going from positive to negative each time. So a sub n equals a sub 1 r to the n minus 1. So a sub n, my first term is 8, and then it's times negative 1/2 n minus 1. Oops. In case you can't read that, I'll just write that again. Once you're done writing this down, you can move on to the next video.